not just utility classes, what they are about, but I'll try to explain why I think utility classes is actually something which should not exist in object-oriented programming. Why they are a bad thing to happen in object-oriented software, and how to replace them with a better object alternative. First of all, let's discuss what they are, what it is in utility class, and I'll show you some example which will demonstrate what is a utility class. Let me share a screen. There you go. So this is a very typical example of a utility class. It's Java. So it's called class, which is math, which is actually very similar to what we have in Java lang, just a standard Java class math. So utility class is a collection of public static methods, which are supposed to be very convenient and very easy to use instruments for basic simple operations with simple data, simple objects, just basic simple procedures, which are supposed to be shared by different other objects, different other classes. So in this example, we have a class math and the method max, which is supposed to calculate the maximum of two integers, a and b, and it basically it compares them and returns a if a is bigger, b if b is bigger. In order to call it, we just do it like this. So we give the name of the class, then we call the method, and then we give parameters, and we get the result. So this is actually technically, technically in terms of Java or in any other language, Ruby or Python or PHP or C++ or other object-oriented language, it is declared as a class, which in reality doesn't have any properties. It doesn't have any normal methods. It only has static methods. That's why it's called utility class. So like in this example, we don't have any. We're not supposed to make any instances of this class. So we're not supposed to do anything like that. We are not supposed to instantiate this class. Everything we do is just call a static method on this class, which is in reality is just a sort of a procedure which does something for us. So even though it's technically is a class in Java, in reality, like philosophically or conceptually speaking, it's not really a class, but a collection of procedures, very convenient procedures, which are supposed to be called from other classes. And before we discuss why it's wrong, I'll show you the alternative, which I think is better, which I think is a good replacement for this utility class in object-oriented programming. I'm just assuming that you understand what it is. I'm not going to go in details and explain what the utility class is for, how it's used. I just assume you understand what this thing is used for, and you've seen many examples of this class. In Java, for example, we have a lot of Apache libraries, and we have from Google, we have Guava library, and Ruby is full of these utility classes. These utility classes are everywhere, basically. So I assume you understand how to use them. And this is what I'm suggesting as an alternative. So instead of, it's longer, but look at this. Let me explain what it does. So in order to calculate the maximum between two numbers, we don't call a method somewhere. We don't go to this fake class and call a static method there. Instead, we create an instance. Look at this line. We create an instance of class max, and we give two parameters to this instance. And now we have the variable x, which is a maximum between two numbers. So if in the previous example, let me show you in details how it works. So first of all, when we instantiate this class, we give two numbers, and they are encapsulated in two private properties. So when we make an instance of class max, we encapsulate number 3 and number 9 inside these private properties, and then that's it. So when we make the instance, we just say that x is a number which is a maximum of these two variables. And then if later somebody will want to get this integer value of the real maximum, then when the call will happen, when this int value will be, when this method, the real method, will be called on an instance of class max, then the actual calculation of actual comparison will happen. So like in the previous example, we also do this comparison. This line is exactly the same as here. So this is the static. This is utility class on top, and here's the line. And here we have exactly the same line. But the difference is that in the first example, we call the method, we call this procedure. I'm saying this is not a method, actually. This is a procedure. So we call this procedure. It does something for us. It makes some calculations, and then it returns the result immediately. In the second example, we make an instance of an object. And then this object, when necessary, we can say like this, for example, and then we want to print it. And then when we print it, actually, when we call this method, then the calculation happens. So on the first line, we just declare that x is a maximum between two numbers. And then later, when we're trying to get the actual value of this maximum, then the comparison will happen. So that's the key difference between the procedural approach and object-oriented one. So I just gave you two examples. I explained how they're different in Java code, and now let's discuss why utility classes, why this is wrong and this is right. So the first argument, which is rather theoretical and rather conceptual, is that in the first example we do the calculation instead of declaration. So on the first example, we thinking as a computer instead of thinking in terms of objects. So I think you've seen enough, so I'll show you my face. So on the first example, we are thinking in terms of procedures and how the computer actually works. So we understand that here we are, and this is the CPU, this is the actual thing which calculates something, and we need to give instruction to this computer, and the computer will make executions for us. It will do some comparisons. It will go through operators and statements and do some calculations for us. So we are thinking as a computer which runs some procedures or subroutines for us. In the second example, in object-oriented, when we create an object, when we create an object, we declare what it is instead of telling the computer what to do. So that's the difference. In the first example, it's imperative. It's based on instructions. While on the second example, it's declarative, where we declare what we're expecting to get. So that's the key difference. The first example is procedural programming. The second one is declarative programming and object-oriented. So we are thinking like an object. Instead of telling our computer, our CPU, that we have two numbers, now go ahead, compare them, and return something back, we are saying that, hey, we need a number which is a maximum between these two integers. We don't care how exactly you're going to calculate that. We don't care how you get this maximum from some calculations. We just know that we need a maximum between these two numbers. So we don't instruct you to do something. We don't go through. We're not operating you. We're not imperatively instructing you what to do. We just declare the intention. That's why it's declarative programming versus imperative. These two concepts I'm not saying that procedural, well, I am saying, but the procedural programming is one way of designing things, and object-oriented is another way of designing things. And object-oriented was invented when it was clear that procedural one is difficult to use when the problem is quite big. So the procedural programming is very useful and very convenient when we're dealing with small amount of code. When we have memory, we have the code instructions, and we basically can put everything into our our head when looking at the code. Then the procedural programming is quite convenient and it's easy to use. The assembly language was the perfect example, well, probably the first example of procedural programming, when we have the memory of the computer and we have the code instructions, which just go one by one, operating with the memory. But then it was clear that we need something else on top of procedural programming, or maybe instead of procedural programming, which will be easier for us to break down complex problems into smaller ones. And that's when, for example, functional programming was introduced, or object-oriented, or logical programming, because these types of thinking are better for us to understand and digest. Because when everything is declared in procedures, in instructions and statements and pieces of data, then we have, in order to understand how it all works, we need to go deeper and deeper into the code and always keep in mind what's going on with the processor, what's going on with the CPU, instead of just staying focused on what we're trying to achieve. So if we are always thinking about procedures where we call, okay, here's two numbers, I give you two numbers, calculate the maximum and get back to me with the result, then I have to remember what exactly is happening there and what I expect as a result, and how long will it take, and what exactly will happen when the processor, when the CPU goes through this procedure. So I need to stay. That's what the debugging is also coming from. So I need to stay with the CPU. I need to go like step by step, and then I jump in, and then jump out. I basically need to think as a computer instead of thinking in terms of my business objects, in terms of my problem I'm solving. So if I'm solving the problem of, I don't know, of calculating the budget and paying some money and calculating the balance of some employee, for example, then the things I'm supposed to think about is employee, payment, transaction, balance. That's the terms I'm willing to operate. But instead, the procedural programming is asking me to operate numbers and instructions and comparisons and the things which are closer to computer instead of being closer to my business domain. And the object-oriented programming is a replacement for that. In OOP, we are supposed to think about, okay, here's the two numbers, and instead of keeping in mind how they will be compared, we just know that we need the maximum from them. We don't really care about this operator of how it will be compared. So I want just to know that this is the maximum of these two numbers, and this is an object by itself. So object-oriented programming, what I'm saying is that OOP is easier than procedural one. The thinking about objects is easier for us will be easier to write the code if we start thinking about objects instead of procedures. And utility classes are collections of procedures. They encourage us to write procedures instead of writing objects. Like I showed you in the example, the utility classes, they put together big amount of small micro procedures which are supposed to be reused but from other objects, instead of making each single micro procedure an object by itself. So the utility classes, they encourage us to get back to procedural programming and think in terms of how we want our calculation to happen, how we want to load the file, how we want to write something to the file, how we want to convert something from one encoding to another one, how we want to decode some text from one encoding to another one, how we want to encrypt the text. So we are supposed to think about how to do it instead of what needs to be done. When we start thinking about in objects, we will say, what do we need? Do we need an encrypted text? Do we need a file? Do we need the content of the file? Do we need a text which is decrypted already or decoded already? Do we need a URL which is already loaded from the web? So we start thinking about what do we have instead of how we create that. So utility classes encourage us to think about how, while objects encourage us to think about what. An object, when we're saying the object, we're saying that maximum of these two numbers is an instance of class maximum. Is a, that's the key point, that's the key part of that. Is a. This is object-oriented, OOP. In procedural programming, we're saying the maximum needs to be calculated by this function. So we're saying calculate it now instead of saying it is a maximum. So that's the difference. And my point is that object-oriented programming is just easier to digest, easier to understand, and easier to think when the software is bigger. When the size of the when the amount of code is big, and we have a lot of objects, a lot of something happening, a lot of events, and like a lot of things to happen, then basically thinking about procedures, thinking about how the processor goes from one procedure to another, it's difficult for us. It's more difficult than thinking about objects. That's what object-oriented programming was introduced for, to get rid of procedures. And utility classes is something which takes us back to procedural programming. So this is, the utility class is something which exists in Java by mistake. It's a step back to procedural programming, to the C programming, to assembly programming, which was introduced in Java by people, I believe, by those who were used to write procedural code in C and all the languages. And they just started to use Java, and they said, hey, where can I put my procedure? I'm used to have a procedure which loads the content from the file. And they said, okay, I need a static method. Let's create a static method, and the static method will be the procedure which I'm used to in C language. And then these procedures started to happen. And that's how we got this Apache libraries, Apache Commons, Apache IO, Apache Codec, all of these libraries. And that's how we got Guava library from Google, the same story. So we have the Guava libraries, basically, it has some classes, but it has a lot of utility classes, which were created, I think, with that mindset, like, let me get back to C and give me the place to put my procedure there. That's what's wrong. And now a little bit, so this is theoretical comparison. So what I'm comparing, I just compared procedural programming to object-oriented, and my point is that utility classes is just something from the past, something from procedural programming, which is 30 years old, and we should stop using them. And now a little bit more practical things. So the first of all, it's objects. It's difficult. The utility classes are introducing hard-coded dependencies into the code. So when I'm using, let me show the code again. So when I'm using the, here you are. So when I'm using this code here, so this is my code. Like, I don't know, this is my function, public void something. And I'm doing this, I'm calling this utility class and the method from the utility class. This is basically a hard-coded dependency, which means that we can't replace it later, for example, for testing. So if I want to test this method, and I don't want this method to call this function, well, in this case, it's not a problem. But if that would be a call, for example, file utils read file, then from Apache, then I don't want this to happen in my unit test. So when I'm calling this method, I don't want to actually go to the disk and read the real file. I want to somehow to mock or to fake this call. I want this method to be safe. I don't want to read it. I don't want it to read the real file, but I can't. I can't do anything with that. So I have no option to replace that hard-coded dependency. So my code depends on the method read file and on the method max from these two utility classes. There is no way for me to make this method configurable, testable, and ready for the test, because these two dependencies are hard-coded. There's no way to break them. In object-oriented, if I use objects instead of that, then I can, if I use new and then I instantiate the class, then I can provide an instance. So if this is my class, for example, if that's the class, and I have, for example, that's the code, then I can say that, look, I don't know, that's the function doing something. And then I want to say, okay, I don't like this anymore. I don't like to use class max. I want something else. In this case, I can probably make, well, it's a simple example, but I can say like, hey, give me a number here, and then I will do it like that. So, or maybe even better, I can say that, so here I'm calling the class max, but I can encapsulate it here. And then I'll say, I don't know, something like that. So this class will be provided as an instance, provided here. If there is nothing provided, I can do a default constructor, which will do like this. For example, so I broke the dependency. So in case of if I want to use the production code, the default constructor will be called, and an instance of this class will be encapsulated. But in the unit test, it will be possible to provide a custom instance of this number, and the custom instance of the number will be used here. In this example, it's not possible to provide anything because this dependency is not break. We cannot make it configurable. Well, in Java 8, we can probably pass a reference to a static method, but that's something from functional programming, which is not what I'm discussing here now. Yes, in Java 8, it's possible to make this fake link to a static method, but in a classic object-oriented, because this is coming from functional programming, but in a classic object-oriented / procedural programming, this link is not breakable at all. So this is coded like this. We have to call this method max, and from exactly this utility class. This is unchangeable. So that's the first problem, the first technical problem from static methods, from utility classes. When you use them, your code is becoming not testable at all. Well, in that particular place. So if you read the file, you read the file forever. You're absolutely hard code linked to this utility class. That's the first problem. The second thing, which is bad with the utility classes, is that when you start using them, then your code is when you start using static methods in general, you have to continue to do that. So you have to continue to use static methods, and you will use more and more of them. So this is like if you jump into this imperative style, if you start using, for example, the file utils, then if you call static methods, then it will be necessary for you to make your code also static in most cases. So you will have to make your methods also static, and you will be encouraged, you will be forced to write your code in a style which will look like utility classes, or maybe you will just make utility classes everywhere. So it's like, why? Because for example, in this example with the method which calculates the maximum between two numbers, if it's a static method which calculates the maximum, then, for example, you want to create something which will calculate, let's say, which will put the number in the interval. So you have the method which choose. Well, let's make it simple. You want to create another something which calculates the minimum. Let's say you have the maximum, and now you want to create the minimum. So for the maximum, you have the static method. from the utility class, which is called math.max. And now you want to create a min. Can you make it an object? Can you make it in a proper way, in an object-oriented way? You basically can't, because you will have to. Well, you can, but you will be more interested to use to create it also in a static way. You will be more interested to create it again, to put another method into utility class instead of making it in a right object way, because technically it will be difficult, because you won't be able to encapsulate anything in the constructor. You will always have to call static methods right here and right now. Instead of encapsulating, like I showed in the example, instead of encapsulating two numbers, you will have to calculate the maximum or the minimum right when they call you. So it won't be possible to, it will be inconvenient for you to encapsulate two numbers first and then call the maximum utility method. It will be easier and faster for you to call it right here and now. And that's why your minimum method will also become static. And that's how it starts to spread over the whole code, over the entire code base. So you will have just more and more static methods, and eventually your entire code will look like just a huge set of different static methods calling each other. So you will stop working in object-oriented way at all. Like, look at it's quite popular in Ruby software. I'm seeing like quite often when you open like this Ruby libraries or Ruby projects. You see many places which are called class, but in reality it's just a collection of static procedures. They're calling each other, and basically you're not in an object-oriented world at all anymore. It's just Ruby syntax, which is a collection of of C or COBOL software in Ruby syntax. And it starts because someone else started to design Ruby classes like that. For example, look at the class called file in Ruby. It has like probably a few real methods and then a huge amount of static methods. So the creators of Ruby started that, and then we need to continue it that way, because this is the way of thinking already introduced, and we just need to, they want us to call these methods immediately, to call these static procedures immediately, and we do exactly the same. Instead of delaying the calls and making our design declarative, not imperative, but declarative with delayed calls, we just call everything here and now, turning our software into statements and operators, and really in a really imperative way. And a few more things. I think, well, that's what I read actually. It's not like my idea, but I think I totally agree with that. That when we always create objects and then let our objects communicate, instead of calling procedures and passing data here and there, this style of programming is more expressive. So just the code just looks easier to understand, and it's more expressive. You can express your ideas way better, because there is no noise for the reader about, like I said before, there's no noise which says how this goal will be accomplished, but instead you just express your idea. So that's why the word expressiveness. So the expressiveness of the code will be higher if you design objects which encapsulate objects, and then just one time you just say do something, instead of making calls to routines, subroutines, and getting some results, and then calling other routines, and then getting results, and then the code looks like a collection of statements. I do this, I do that, and then I call this, I call that. It's just step by step, one by one, like an assembly code. In object-oriented, it's more like you declare the maximum between these two numbers, and then you don't do anything about it. You just pass this maximum to somebody else who needs this maximum. So it's not like you calculate the maximum, you get another variable, and then you continue to do something. Instead, you create a variable which is a maximum of two numbers, and then you let it live its own life. Maybe you don't even label it like a variable. Maybe you just let it be encapsulated in something bigger object. So So that's the expressiveness. So the code will be more expressive because of the using of new operator instead of the assignment operator. Instead, so you just build objects, and you rarely call actual methods of these objects. You basically build them. Most of the time in object-oriented programming, you build objects, and just in small and a small amount of code, you actually instruct them to do something. While in imperative programming, you basically spend all your time and most of your lines of code for doing something, for calculating here and now, for looping, for switching, for comparing, so you just doing some real operations, some real real statements and instructions. While in OOP, you declare, encapsulate, you build objects. And then when the entire object is built properly, then it starts to live, then it starts to work. And this work is kind of hidden from us. So we don't really spend our attention to understand how it works. Instead, we spend time on understanding what is built. What is it? Is it a maximum between these two numbers? Yes. How it's calculated, we don't care. Instead of saying, hey, do the calculation, calculate the maximum of two numbers, and return it back to him. That's the change of the mindset, and it improves expressiveness of the code, which means maintainability and readability of the code. That's what I'm trying to say. So the code will be more expressive and more readable for the users. And I think we're half an hour there, so I'll let you ask questions. I think I said enough about that. So you're ready to, you can post your questions there. And while you're asking questions, I'll try to answer one question which was asked on the blog post which I wrote about utility classes. The question is, what about the practical aspect of utility classes, of static methods in general? So it's very common question, and it's very common problem, and even Android platform actually suggests, officially tells programmers that we have to use static methods instead of making new objects. So that's what Android says, the entire platform. So it says you should consider using static as much as you can because it's faster. Because every time you create a new object, like in this example with the maximum between two numbers, if you just call the method called max, then you just compare two numbers and you get the result, and that's it. But if you make a new object, which is called an instance of class max, and it's definitely slower. So it definitely takes more time. We allocate some memory, we encapsulate these two numbers, and then it's just more operations, more steps to complete for the CPU, for the processor. And that is definitely true. But at the same time, I think it's I'm not arguing about Android. They have their own problems with the implementation probably, and then they are fighting for speed. But I think that making an object and working with objects instead of static methods is instead a faster way. Not because making an object is faster. Yes, making a new object is a slower operation than just calling a static method. But on a bigger scale, this is way easier to optimize the performance when we are working with objects instead of calling methods. Because when you call methods, when you call static methods, you definitely spend time on the processor to call, for example, to calculate the maximum between two numbers. So if you have two numbers and you need to calculate the maximum and then to use this maximum for something else, then the calculation of the maximum will happen anyway, will happen always, even if you don't need the number afterwards. Let's say, for example, you compare two numbers, you calculate the maximum, and then you do some other comparison and you throw an exception, like something went wrong. So I don't need this maximum because something else went wrong. But the calculation happened already. So you already spent time on the CPU to compare these two numbers and to store the result into the variable. And then something else happened and you don't need this number anymore. So with the procedural programming, with imperative programming, it's inevitable because everything happens here and now. It's not declarative, it's imperative. We just say to the CPU, do it now, do it here and now. We have the data for you. Calculate, do some comparison, make the calculations with the data, run it now, give me the result back. Imperative way. So even if it's faster, so yes, these operations are faster. The comparison of two numbers will happen faster, but I can't optimize it anyhow as a developer. With the objects, I can optimize it way better because I can see that I can delay all my calculations to the latest point in time. I can calculate it as when it's really necessary. So when you build objects, like I said, in object-oriented programming, you basically spend most of the time to build objects. Most of your lines of code are supposed to be about building objects, not about making calculations. So when you build objects, you make new different objects. You encapsulate one into another, encapsulate. And then when it's time to run the calculations, you say, okay, now calculate it for me. And then the optimal path will run. So you will execute only the calculations which you actually need. In imperative way, you do all the. It's very difficult to optimize because in order to optimize, you need to think ahead. You need to put a lot of if. You need to think of how to position your calculations properly. What happens before the forking? What do you put after the forking? So the optimization is way more complex, way more difficult, because mostly because of the nature of imperative programming, because everything happens here and now. While in declarative way, you declare the object and then you don't touch it. I declare the maximum, I don't touch it. This is the maximum between two numbers. You need it, you will call it, you will get something from it. And when you call it, it will calculate it for you. And for example, if you need to cache something and say, hey, I don't want to calculate the maximum, multiple times. If somebody calls me, I just want to be able to return the previously calculated number or whatever. Or if somebody says, I need the content of the file, and I don't want to read the content of the file many times. I just want to do it once. In an imperative way, it's really difficult to cache these results. It will make your code noisy and full of supplementary caching mechanisms. When you use objects, you just create an object which is smart enough to cache itself, and then you just call it as many times as you want. And the optimization happens inside the object. So the code is cleaner, it's more transparent, and it's easier to optimize it when you put everything into objects and manipulate with the objects which know what to do inside themselves, not outside. And it's always in a declarative way. So you just declare an object, and only when you touch the object, it actually does something for you. So that's the answer to that question about the performance optimization of why. Of what is faster, utility classes or real objects. So I believe that real objects are way faster because they are way easier to optimize. So that's the difference. Technically, they are definitely slower because it takes longer to create an object. But on the long term, it's way easier to make the optimizations, So that's what I think about the performance problem. One more question about the single responsibility principle, which is quite common in not only object-oriented programming but everywhere. It was also posted on the blog, and somebody said that what about this SRP? So what about this single responsibility principle if we make and actually the answer is that, well, the question was like the utility class is more like for someone it looks like a place where you concentrate the code which is responsible for something. While when you make objects, then for example, you make a utility class where you have methods which are responsible for example, file operations. So you have one place for procedures which are making something with files, with operations, some routine operations with files. But if you put them into separate places, if you introduce multiple objects, and each object will be responsible for a certain operation with the file. For example, one object will be about reading the file, another one will be about the writing, another one will be about calculating the size of the file, something like that. Then we will lose the cohesiveness in these classes. And my answer is quite the opposite. So I think that if you look at any of these, for example, Apache classes, the file utils or input-output utils, then you will see how huge these files are. Some of them are like 5,000 lines of code. So it's just we can't just say that these huge monsters are actually obeying the principle of single responsibility. So they are responsible for a lot of things, even though there's a lot of things looked for us like one thing, like file operations. But in reality, they are inside. They are doing a lot of different things, a lot of different operations, which are not really, staying close to each other, that are not really related to each other. Because the problem with utility classes is that it's really difficult to break it down into pieces. So when it starts to grow, it's just a monster huge piece of code, which is very difficult to break down into elements, into sub pieces, because when you tend to put more and more into these utility classes, and the size of methods, they start to grow, and at the same time the amount of methods grow, and then the more you introduce, the more functions you want to introduce, the more static methods you get, and in the end you get a huge long file, huge long class, which is not really a class, which is difficult to break down into pieces because these methods, the static methods, they depend on each other quite heavily. Instead, if you break it down into smaller elements, and then you can create sub-elements, subclasses, sub-objects, which will stay which will exist just for the purpose of helping these bigger classes. So you will have some kind of a hierarchy of classes, hierarchy of objects and classes, which are responsible for their own things. And if you design it properly, it's more difficult. I agree. It's difficult to design it properly. It's difficult to do it right. It's much easier to just use one long in the beginning. It's much easier to just use one long file, put many static these utility methods there, and they will be connected to each other. It's easier. But in the end, when you start to maintain this monster, you will realize that it's extremely difficult. You will be just the code will become bigger and bigger and bigger. It will just grow. So on the long run, smaller objects, micro objects, are way more maintainable, code organization than utility classes, and they will be more, cohesive and solid, and they will be responsible for one thing. Each class, each object will be responsible for one thing. So this single responsibility principle will be actually obeyed in a better way if you do micro objects instead of utility classes. That's what I wanted to say. That's probably it. We're already 45 minutes here. So I think we don't have any more questions. If you have questions, you have like 2 minutes to post them. Otherwise, I'm going to get one more question from the blog, and we are done. The question is that in Java or in other languages, I'm talking about Java, sometimes it's not really possible to use objects instead of utility classes, unfortunately, and that's true. For example, because Java as a language is designed with this, procedural imperative way of thinking, I think, and that's why some of the core key elements of Java are not really suitable for making objects. For example, the string class is final. So for example, we want to introduce a concept of encrypting a text, then the right way, the object-oriented way, would be to create a class which we would call encrypted string. And then we just encapsulate the original string into the object of class encrypted string. And then this encrypted string will behave like a string with encryption. But we can't do that because the string, the class string, is final in Java. So we can't extend it. We can't do anything about it. So the only way for us is to use utility class and some static method, which will actually get the string encrypted and return the encrypted string, which is really sad. But that's kind of the only way in Java to do it, in an optimal way. So Java is not the perfect place for writing the pure object-oriented language, unless you decide to rewrite the majority of Java classes, like string, for example, or integer, or float. Integer is also final. So this class is not suitable for object thinking. This is unfortunately. So in Java, maybe some utility classes, I can understand why they appear there and why we have to use them, because we don't have an alternative. And some alternatives are not technically possible in Java. So, but even though we have to use sometimes these utility classes, we have to remember that this is our situation, not our. This is not what we love. This is not what we like. This is not what we. This is not how we want our code to look. But this is how we are. This is how we. What's the right word? We have no choice, basically. So we have to be there. We have to use these utility classes sometimes because of the problems in Java. But let's keep in mind that in general, in the right way, the object thinking is way better than static methods for the reasons I just mentioned. So that's it for today. Thanks for coming. Thanks for joining. See you next month, the first Wednesday of the month, 11 a.m. PST, Pacific time. Bye-bye. See you.